Hello everyone, I am Raj, Assistant Professor, ECE Department from ABES Engineering College. Would like to present my topic on flash type A to D converter. So first, to understand what is a flash type A to D converter, we should at least know that what is a A to D converter. So whenever we talk about A to D converters, we generally deal with a block that is having analog input, then it has a reference value, and then it has a conversion technique. Whenever we talk about A to D converters, we generally take a block that is comprised of a circuit. Here we call it ADC. Then we will be applying an analog input. Analog means which is continuous in time and amplitude. And this input is further converted into digital domain, going from MSB at the top and LSB here. This is the digital output, and definitely there is some logic in the circuit which is going to help us in converting an analog data into digital. So for conversion we require three more inputs. First is the start of conversion. We require this to be high. Then whenever we need to end the conversion, we need to deal with this value, and here we require a reference voltage, or you can say a reference current, whatever the form of your analog input is. So this is your A to D converter, basic of A to D converter. Then we calculate a value D, which is actually D1, that is the MSB, upon 2 to the power 1. Then we have plus D2, 2 to the power 2, D3, 2 to the power 3, till Dn, 2 to the power n. So we are actually dividing our LSB value by the maximum value of number of bits. So that is why it is termed as LSB, because it has the least important value. So this total D, that is the input voltage, is equivalent to this combination, where n is the number of bits, that is in binary. Now when we specifically talk about A to D converters, then there are different types of converters. So those different types are generally categorized as two types. One are the direct type of A to D, direct type ADCs, and another is the integrating type. Now the topic that we are going to discuss is the type of direct type ADC, that is a flash type A to D converter. There are lots more, but in this lecture we'll be discussing about flash type A to D converter. So this is the circuit or a block diagram for a flash type A to D converter, and for this we require three specific components, that is resistors, which are applied here at the input. Then we have comparators and a priority encoder. These are the three things that we require the most. Priority encoder in count is always 1. Here the priority encoder which is used is 8 to 3 line priority encoder. Now how do we decide the number of resistors and comparators? This is decided according to the number of binary bits we are converting. As in this example, we are having 3 bits. So the number of resistors and comparators will be decided by this 3 value. This 3 bits is equivalent to n, and number of resistors will be 2 to the power n, whereas number of comparators will be 2 to the power n minus 1. So in this case, number of resistors will be 8 and number of comparators will be 7. So specifically this flash type of A to D converter is a 3-bit flash type A to D converter. Now what happens here? We'll be dealing each and every component one by one. So here we are talking about comparators first. What is the task of a comparator? Comparator is an op-amp that is having two terminals, positive and negative. We'll be applying two values at these terminals and then we are receiving one output. So the logic of that output is, here we'll be applying the positive terminal. We will be using, as mentioned over in this diagram, positive terminal is always the input. This is the positive terminal and we have applied V input here. So in positive terminal, we will be applying V input and in negative terminal, we will be applying V reference. Now after comparing these two values, we will get output. So if the V input is greater than V reference, the output will be high, that is 1. If V input is less than V reference, output will be 0. And in case if the V input is equivalent to V reference, then what will happen? You will have to pick up the previous value. That is, if the value is 0, you will be considering 0. If the value is 1, you will be considering 1. So this is the purpose of comparator. And total comparators we are using here are 7. So you need to deal with 7 comparators in this type of circuit. These are the 7 comparators. This is a priority encoder. And these are the 8 number of resistors that we have used. Value of all resistors are approximately same. Now, how these resistors are giving us the value? See, V input will remain same for each and every comparator. Every time the value of V input will be same. But the value of V reference, which is applied at the negative terminal, will change. And it will change according to the resistances applied at the input. Now, this value will be calculated by using another concept, that is voltage divider rule. Now, what this rule says? It says that if we have applied a voltage in a circuit like this, where there are two resistances, supposedly R1 and R2, and we need to calculate the voltage across R2, then it will be calculated by V output is equivalent to the resistance across which we have to calculate the voltage and sum of the other two resistances. And this whole into the input voltage. So this voltage divider rule concept we'll be using here. Whenever I need to calculate the voltage at point V7, it will be equivalent to this resistance, sum of all these resistance. These total resistances are 7 R upon 7R plus R into V reference. So it will become 7 upon 8 V reference. So at this point, the voltage is 7 by 8 V reference. Similarly, if you calculate V6, it will be 6 by 8 V reference. This will be 5 by 8 V reference. 4 by 8 V reference. 3 by 8 V reference. 2 by 8 V reference and 1 by 8 V reference. Here we will be calculating the output of this comparator by giving it two inputs, that is one is the part of the input and another is the voltage that has been applied at the negative terminal. And the output at the comparators, the output of comparators will be calculated by the logic given over here. So according to this, there will be some binary values at these points, these all 7 points. Now, how the priority encoder works? Priority encoder says that, we'll see this table. Priority encoder says that if it says that the highest priority will be given to the output, which is the uppermost. Uppermost means if we are considering this circuit and the output of 6th comparator is 1, then we'll not be seeing the output of this and this. We'll just be focusing upon the higher point of the comparator, that is the comparator number 6. Now, if this one has the, here it is 0 and 1 is at the comparator number 5. So, we will be giving the output according to the comparator number 5. So, this table will be used here, which says that if the output of 7th comparator is high, then we'll be taking the output as 1, 1, 1, which is the binary conversion of value 8, right? Similarly, here we have given 1, 1, 0. This is the binary conversion of 7. And here the comparator number 6 is at the higher value. The priority of this comparator will be considered, not considering whatever it is in the 7th one or at the 5th one. We'll only be talking about the highest priority, and that is given to x6. Here it is x5, then it is conversion of 6, 5, 4, 3, 2, 1, 0 accordingly. Okay, so this is how your flash type A to D converter works. Now see, the biggest advantage of this circuit is that it has the fastest conversion time. Fastest conversion time. And why is this fastest? Because here the input is fed into different comparators parallelly. This is the biggest advantage, that the conversion time of this type of system is very less. And why it is less? Because of the parallel inputs. But again, if there is an advantage, there must be some disadvantages. And here the disadvantage is that the number of resistors and comparators increases as the number of bits increases. Means it is dependent on the value of n. Like we see in 3-bit comparator, we have seen that if n is equals to 3, we require 8 resistors and 7 comparators. So if we increase the value of n, the number of resistors and comparators will increase, and thus the system becomes bulky. So, but still, even after this disadvantage, it has the fastest response because the conversion time here is less. So this is all about your flash type A to D converters, and these are the references that are used. Thank you.